Welcome back, students. This is example number 7 from the in-class practice notes sheet I gave you on December the 3rd on System of Inequalities. First thing you notice is that both inequalities are not in slope-intercept form, but we could easily change them to slope-intercept form. So let's go ahead and do that. So we start off with the first equation, 4x minus 3y is less than or equal to 9. Well, we got to get negative 3y by itself because we want y alone. So let's get rid of this 4x by undoing it and moving it to the other side of the equals. So if we do that, we get negative 3y is less than or equal to negative 4x plus 9. All right, now we got to get this negative 3 away from this y. But do you remember the rule for inequalities? There was only one, and it stated that anytime you multiply or divide an inequality by a negative number, you had to remember to flip the inequality symbol. So let's go ahead and divide everything by that 3, negative 3, to get rid of it. Well, negative 3 divided by negative 3 is 1, and 1 times y gets you to y. These two are negative, so since they're both negative, you're going to turn around and cancel the negatives and becomes a positive 4/3 x. This is a positive 9 divided by a negative 3, so that answer is a negative 3. And now you have the equation in the correct form. So what we're going to do is we're going to go ahead and find m, which is equal positive 4/3, and b, which is equal to a negative 3. So here's what we're going to do next. We're going to take this negative 3 and we're going to graph it on our graph. So we're going to take negative 3, going to go back to the origin, and we're going to go down 3 units, 1, 2, 3, and make our first dot. Remember, b is the y-intercept. Now we're going to come up here and look at our slope and realize our slope is a positive 4/3, which means we're going to go up 4 units and to the right 4 units. So let's go over here and go up 4 units, 1, 2, 3, 4, right 3 units, 1, 2, 3, and that's where our first dot is going to be. So now we have 2 dots, which is sufficient for us to graph. So we're going to go ahead and put our trusty ruler in place. Go back to the original equation and you look at it and you realize, hey, this was a inclusion. So we need a solid line. So here we go. We're going to connect the 2 dots with a solid line. And you'll have to forgive me because I forgot my ruler at school and I'm using an envelope as a ruler. All right, don't forget the arrows on both ends. Now we got to find our half plane. And again, for our half plane, if 0, 0 isn't on the red line, it is okay to use it. Since 0, 0 is not, we are going to use the ordered pair 0, 0 and always go back to the original equation, which was 4x minus 3y is less than or equal to 9. All right, x goes to 0, so that gives you 4 times 0. Y goes to 0, so that gives you 3 times 0, less than or equal to 9. So what we're going to do now is we're going to go ahead and say 4 times 0, 0, 3 times 0, 0, 0 minus 0, 0. So 0 is less than or equal to 9, which is a true statement. Since it is true, we're going to shade everything going upwards on this line. In other words, toward 0, 0. And try not to go over the boundary line, which is the line you graphed. Now we are ready to start the second equation. For the second equation, we are going to start with the original equation, 4x minus 3y is greater than negative 6. We want to get this 3y by itself, so let's move this 4x over as its opposite, and now we get negative 3y, is greater than negative 4x minus 6. Same issue here, because this is a inequality and you're now going to divide by negative 3. You got to remember to flip the inequality symbol. So let's divide everything by negative 3, and I mean everything. And we cancel, and this just gives you y. Over here, same situation. Negative times negative is a positive, so you get a positive 4/3 x. Negative 6 divided by negative 3 is a positive 2. So now we could find m equals 4/3, b equals 2. All right, we're good to go. We're going to take this b and graph it. So we're going to come all the way over here to the origin, and we're going to go up 2 units, 1, 2, and that's where our first dot is going to go. Now we come over here and we see that our slope is a positive 4/3, so we're going to go up 3 units, up 4 units, and to the right 3 units. But notice when we try to do that, 1, 2, 3, we got a problem. We can't go 4. So we ran out of room. Remember, when that happens, you are allowed to change it to a negative 4/3, but this time you're going to go down 4 and left 3. It's got to be reverse. If not, it doesn't work. So let's go back to our original point, and we're going to go down 4, 1, 2, 3, 4, and now we're going to go to the right 3 units, 1, 2, 3, and this is where our next dot is located. We go back to the original equation and we realize, hey, it is in exclusion. So we're going to have to use exclusion for this one. So here we go. Exclusion means dashed line. So we're going to connect these 2 dots as best we can, and we're going to create a dashed line as straight as we can get it. Of course, you guys will have rulers. Again, I'm using an envelope. And we're going to put arrows on both sides. Ooh. Arrows on both sides. And now we're ready to check to see where our half plane is located. So to check to see where our half plane is located, we always look at the origin. You'll notice right here, there is the blue line here, and it's not on this ordered pair. So 0, 0 is what we're going to use. So use 0, 0. Always go back to the original equation in case you made a mistake. The original equation was 4x minus 3y is greater than negative 6. So plug in 0 next to the 4 for x, plug in 0 for the y, greater than negative 6. 4 times 0 is 0, negative 3 times 0 is 0, 0 minus 0 is still 0, so 0 is bigger than negative 6, and that is a true statement. So we come way over here, back to this, and we realize we have to shade in this direction, but we're not going to go over this boundary line, so we start over here and start shading everything between these 2 lines. And that is where our solutions are kept. It's only the double shaded area. Again, if we want to check it, just remember we kind of already did, because look, 0, 0 was between the 2 boundary lines and both came out as true. Well, I hope this helps. Again, sorry it took so long, but I had to do all the explaining. And I'll be posting a video on how to do a word problem.